Hello everyone, I'm going to start class today by taking any questions over Friday's assignment, which was the entire Unit 1 review. I'll take questions over those. I had all the answers with the work posted, but still let me know, even if you want to email me ahead of time. That way during our Zoom meeting today, which I encourage everyone to attend, you can ask and I'll know ahead of time which questions you'd like to see. So it was a Unit 1 review as well as the function notation worksheet. All right, so today we're going to do this in kind of two separate parts. Now, with your quiz being tomorrow, the stuff we're going over today is not on the quiz, so no absolute value graphs will be on the quiz, and we're going to start factoring as well today. So that is just to kind of fill in. I didn't want to give the quiz today, but I will tomorrow, but none of this stuff is going to be on the quiz. So let's take a look at how to graph. Again, we'll just call this basic graphs absolute value functions. So go ahead and get out preferably graph paper. If not, notebook paper is fine, but please make sure you have a ruler. Pause the video to graph this, to make your coordinate plane. And we're going to take a look at this first graph, just y, what we call the parent function, y equals the absolute value of x. See what you remember about it. So hopefully you remember that this is a V-shaped graph, and when it's just this parent function, our vertex, or the bottom of the V there, the corner, starts at the origin. And then as we go off to the right, we're going up one, right one, because we have a slope of 1 really that's out in front here. And then we do just the opposite. We're going to go up 1, left 1. That's what gives us our V shape. Or if you notice, if we took the absolute value of -1, we get a +1. Absolute value of -2, we get a +2. So we get a graph that takes on this V shape. And we're going to label this. We'll just put number 1 next to this. All right, so our next two shift a little bit, change or what we call transformations on the parent function here. So again, look at number 2, see what you think, pause the video. So the easiest one to spot is this, either a plus a number or minus a number that's going to be at the very end outside the absolute values. This is going to shift our graph up 2 units. And then what's inside here, we usually do the opposite. So if there's a minus sign, which normally we would think it means to go left, this is actually going to be 4 units to the right. So we're going to go 4 to the right and 2 up. So there's our new vertex. Our slope is still going to be the same when there's nothing out in front. It's just going to be a 1. So again, going to the right, I'm going up 1, right 1. And then to the left, I'm going up 1, left 1. That's what gives us our V shape again. Call this number 2. All right, and then go ahead and see what you think number 3 is going to, how that's going to look a little different, having that 2 out in front. But just like number 2, we see something inside and we see a plus sign, so again that's going to be the opposite when it's inside, a horizontal shift. So this is going to go 3 units to the left, but it's not going to go up or down any, so I'm going to still stay on the x-axis. I'm just going 3 units to the left. Now this 2 out here is acting just like a slope, so as we go to the right, we're going up 2, 1 to the right, so it's actually making our V a little skinnier. We call this a vertical stretch, as if we were to take the bottom and the top and just stretch it vertically, it becomes skinnier. And then as we go to the left, we're going up 2, 1 to the left. And then here's our third graph. All right, so just to review some basic graphs, we'll do a little bit more with these later. Next, we're going to take a look at factoring. So we have to go through a little checklist. Everything in algebra has a process, so we just have to remember the process. First, we always need to look at the problem, and as long as it's just in one variable, we want to ask ourselves, is this in order? Usually if it's 2 or more variables, we'll talk about that, but in most cases we just leave it be. But if we have, for instance, like a 3x squared plus a 5x and then minus a 6, so we're looking at the exponents. We want the term with the largest exponent to go first, and then afterwards it just, the exponents keep decreasing, and then constants always go last. Second, if there's a GCF, we factor it out of there. We're going to work with smaller numbers that way. So we always want to work smarter, not harder. Second, we have to ask ourselves, how many terms are we looking at? So if it's 2 terms, today we're going to focus on a difference of squares. Later on this week, we'll look at a difference of 2 cubes or a sum of 2 cubes. But right here, if we have a difference of squares, means we're subtracting 2 terms that are perfect squares. So we make 2 sets of parentheses. Let me actually go back to write this out. So we make 2 sets of empty parentheses. This is how I do most of my factoring. I know some of you still have like that X in the box method, which is fine, but we're trying to evolve from that and use that kind of like as training wheels. But if you still need to use that, that's fine. If not, let's kind of jump right in here. We start by taking the square root of a squared, which will be a, no matter what that term is. Then we take the square root of b squared, which is b, and then one set gets a plus sign, the other gets a minus. It doesn't matter where it goes. Now, if there's 3 terms, we call that a trinomial, and it's usually just try and check, trial and success. And then eventually we'll get into 4 or more terms, which usually means to factor by grouping. Back in Algebra 2, you guys should have seen polynomial long division or synthetic division, which we're not going to get into this year, but the grouping we will, factor by grouping. All right, so let's take a look at these. Please pause the video to copy down 1 and 2, leave some space, and we're going to go through a little checklist. All right, so 1 is a trinomial. We have 3 terms. If you notice here, it is in descending order. We've got the x squared term first, then the x to the first term, then our constant. Now there is a GCF. Hopefully you're looking at it and thinking it's 3. You would be thinking that correctly. So I want to factor out the 3, still write what's left over. I might not be able to get this into 2 sets of parentheses, so we always have to make one big set here. So if I factored out a 3 from a 3x squared, I'm just left with x squared. In the middle term, and factoring out is the same thing as dividing. So if I divided a 3x by 3, I'm just left with an x. And then factoring out a 3 from a 6, I'm left with the 2. Now what I want to try to do is factor this trinomial into 2 sets of parentheses. I still leave the 3. This is where we're just going to try and check. And there's little clues in the problem. So first, we just start with the x squared. What's the only way to factor an x squared? X and x. Next I should say, we go to the last term that's here, and the only factors of 2 are 2 and 1, and I can't go wrong because both x's are first here, so I could put a 2 then a 1, or really a 1 then a 2. Then we pay attention to the sign of this last number. If this is a minus, our signs are different, which means we want 1 plus or 1 minus. Well, here it does matter where they go. Since there's a plus sign right here, I need the larger number to be positive. So this is how I check for the larger number. I take my outside terms, because sometimes we can have different coefficients in front of the x. So this is a 1x, and up here this will give me a 2x. So that's when I check, I call them my outside and inside terms. So the 2x is the larger one, so I want to put the plus sign here and the minus sign here. So when I go to check this, x times x is x squared. I'll get a minus 1x on the outside, plus 2x on the inside. That'll give me my plus x right here. And then 2 times negative 1 is that minus 2 at the end. So I know I have all this work kind of around it, but here's our final answer. 3 times the quantity of x plus 2 times the quantity of x minus 1. And those are just different ways, kind of like puzzle pieces. We first put them in and then we see if they fit. All right, looking at 2, again, ask yourself, this is a trinomial, 3 terms. Is this in order? It is in order. Is there a GCF? And in this case, no, there is no GCF. So I'm going to go straight to making 2 sets of parentheses. And when we work with prime numbers, that's really the best. Remember, a prime number can only be divided by 1 and itself. It has no other combination of factors. So what's nice is 5 is prime. So the only way to factor a 5x squared is a 5x and an x. Or I could put x and 5x. You're going to see I always like to put the coefficient 1 first if there's the next one is just a 1. All right, so next I look at the 6. I'll make the 17 work here in a little bit. Factors of 6 are 6 and 1 or 2 and 3. And what else I want to point out is this sign is positive, so when the sign of the third term is positive, that means the signs are going to be the same. What are they both going to be? They're both positive. So I could go ahead and put a plus and a plus in here. And that makes this problem a lot easier. So here's a nice way to check. Whatever goes here is going to get multiplied by the 5x. Whatever goes here is going to get multiplied by x. I need to get to a 17. We could try 6 right here, but 5 times 6 right away is 30. We're too large. We're going to put a 1 here. 30 and 1 won't get us to 17. If I tried a 1 here and a 6 here, that's going to give me a 5x and then a 6x. And it's larger, but it's an 11x, so that's not going to work. So 6 and 1, not really working. Let's try a 2 and a 3, and hopefully you guys can kind of look at these ahead of time. If I put a 3 there, that's a 15x, and then I want to put a 2 there, so that's a 2x, and they're both positive, so 15x and 2x will give me that 17x in the middle. So again, after all of this writing that I have around it, our final answer factored form is 5x plus 2, and then an x plus 3 in the other set of parentheses. All right, looking at number 3, we have a much larger exponent here. So we're looking at 8x to the 10th minus 8. So right now this is 2 terms. 8 is not a perfect square. We can't take the square root of 8 and get a nice whole number. So chances are there's a GCF, and if you notice 8 shows up for both. So I'm going to factor out an 8. Then I'm going to have an x to the 10th minus 1 left. Well, now this, I'll leave the 8. Now this x to the 10th minus 1 is a difference of squares. When this exponent is even, we can take the square root of that power of x. So I'm going to make 2 sets of parentheses. And what I do, I split this in half because they have to be identical. So the square root of x to the 10th is going to be x to the 5th, because x to the 5th times x to the 5th will give me x to the 10th. Square root of 1 is just 1. And then I put a plus sign in one, minus in the other. Doesn't matter where they go. And then I would check. If I look at this x to the 5th minus 1 because there's another minus sign, I would ask if I can factor this again. But because that exponent is a 5, it's odd. No, we can't split that evenly. So we're just going to leave it like this, and that is this binomial expression factored completely. All right, I'll give you guys a moment. Go ahead and try 4. Now for this, because there's 2 variables here, the order doesn't matter. Also because it's just 2 terms. So let's see, ask yourself, is there a GCF? If there is, factor it out, see what's left. Okay, so if you notice, there is a factor, a common factor of a 3. And then they each have a b, but not an a, so I could factor out a 3b. I still need to make a set of parentheses to show what's left over. So if I factored out a 3b from the first term, I'm like taking those away, I'm dividing by them so they're gone. I'm left with an a squared minus 3 times what? 3 times what will give me 27, that'll be a 9. And then I took the b out, so there's no more b. So I have 3b times the quantity a squared minus 9. Well, now this is another difference of squares. So we're going to make 2 sets of parentheses. Take a moment to see what you think is going to go in them. Again, I want to factor, or take the square root of a squared, so that's just a. Square root of 9 is 3. And then 1 gets a plus, 1 gets a minus. Again, it doesn't matter where it goes. All right, sometimes when we see numbers come first and differences of squares, we think it's backwards, but it's perfectly fine. 2 terms are in order one way or the other because there's only 2 things. They're either going in ascending order or descending order, so it's perfectly fine to leave this. It gets messier if we try to reverse it. We'd have to factor out a negative. It's too much work that way. So let's just leave it this way. With the 81 first, it is a perfect square. N to the 4th, because that 4 is an even number, that's also a perfect square. There is no GCF here, so I'm just going to start by making 2 sets of parentheses. Start with the square root of 81, which is 9, so 9 is going to go in there first. And then the square root of n to the 4th would be what, guys? Half of that 4, so it's going to be n squared and n squared. Then I get 1 plus sign, 1 minus sign. But we still have to look to see, especially with the minus, the difference here, can we go further? And yes, because 9 again is a perfect square. Again, square root of 9 will give me 3. And it's okay, the number's going first, that's perfectly fine. Square root of n squared will just give me an n. Again, 1 plus, 1 minus. And then I still have to bring down the 9 plus n squared. There's nothing I can do with that. All right, so take a look at 6 and 7. Now I will point out 7 has 2 variables, so the order we're not too worried about, But let's see if there's a GCF and what's left over. So pause the video, give 6 and 7 a try. All right, so let's see for 6. Again, 2 terms, so this is in order one way or the other. There is a GCF of 5, and we're going to be left with an x squared plus 5. Now we would want to look to see, is x squared plus 5 a difference of squares? No, for 2 reasons. It's not subtracting, and 5 right here is not a perfect square. So all we could do in this case is factor out a GCF. All right, for 7, looking at numbers for GCF, they don't have any, but notice there's an m and an n in each one, and the most we can factor out is just 1. So if I factored out an mn from the first term, I would be left with a 6 and then another m, because I had 2 m's there, but no more n's. Next in the middle would be a minus 5. I took out all the m's, there was only 1. I still have 1 more n though, because I only 1. And then the very end, so with this very last term, there's really a 1 in front. So if I took out or divided or factored out the m and the n, I'm still left with the minus 1. And we can't go any further than that of what's inside. All right, so for number 8, I want you guys to try this. Clearly the numbers are large. I will tell you this is in order. It's a trinomial in descending order. So see if you could determine a GCF and see if what's left over can be factored any further. So pause the video and give that a try. All right, so we would always like to start with the smallest number, which is 12. Now 12 goes into 24, but it doesn't go into 28. Then we might want to try a 6. 6 goes into 24 and 12, but not into 28. So hopefully you guys were looking at this in just in numbers. What we could factor out would be a 4. So what this would leave us with first is a 6x squared plus a 7x minus a 3. Now I want to try to factor this trinomial. So I still bring the 4 down. I'm going to make 2 sets of parentheses. And again, we're just going to try. What we can do off to the side here, write out factors of 6, which are 6 and 1, 2 and 3. And then we have factors of 3, which are just 3 and 1. We need a combination so that we get a 7 in the middle. Now, because this last sign is a minus, our signs are going to be different. So I'm going to need 1 plus and 1 minus, so that means my 2 numbers need to subtract to a 7. So I'm just going to start this just to show you guys. If I started with the 6 and the 1, and I did a 6x and an x, what's nice is 3 is prime, so I don't have too many choices. I could do a 3 and a 1. Well, now if I check this, I'm going to get a 6x on the outside and a 3x on the inside. And if I were to subtract those, I'm definitely not going to get a 7x in any way. So I'm going to actually just erase everything, and that's okay. This is what trial and success means. So the 6 and the 1, the 3 and the 1 didn't work this way. Even if I tried it 6x and x, 1 then 3, on the outside I'm at an 18, on the inside I'm at a 1x, 18x and a 1x. That's not going to get me to a 7x. So I'm going to rule out the 6 and the 1. Let's try the 2 and the 3. So if I try a 2x and a 3x, next I'm going to try the 3, then the 1 first. So on the outside here, I'm going to get a 2x. On the inside, I'm going to get a 9x. Now keep in mind, we need to subtract these. Our signs are going to be different to get a 7x. 9 and 2 will subtract to give me a 7. And because this sign's positive, I'm going to put the larger term needs to be positive, which means the 9x. So that means I need the plus sign to go here, and then the minus sign to go there. So this will give me a 2x, negative 2x on the outside, 9x, positive 9x on the inside. That will give me my 7x. 2x times 3x will give me 6x squared first. 3 times negative 1 will give me my minus 3 at the end. So just to rewrite this so it looks a little nicer, our factors are 4, the quantity 2x plus 3, and the quantity 3x minus 1. Alright, so I'm going to assign this basic factoring gift. It's a worksheet. It has 30 problems on it, but I'm just assigning the first 15. Keep in mind, look at your review, the Unit 1 review and the function notation worksheet. Also go back and look at your team assessment. to practice, to prepare for this individual quiz tomorrow. The Unit 1 test will be someday next week. I'll let you know. Around 17 problems, about 50 points. Again, no calculators on the quiz or on the test for next week. Please let me know if you have any questions. I'll post this as a separate PDF, but here is the worksheet. It's just going to be the first column, so you could pause the video to copy these down. But like I said, I'll post this as a separate PDF, so you're just doing the first column. Now, some of these may look familiar. You should know how to do these, so just up to 15 here. We'll finish with 16 through 30 another time. But just wait, if you do have questions, I do plan to go over these for sure. Just give these a try. Let me know if you have any questions.